The 5 rules of scientific approach are: question, observe, hypothesize, experiment, and conclude. Now, today's question is: how can we modify this to shoot faster? Now, the basic principle behind a Nerf gun shooting bullets is a spring which is cocked, and that spring, when released, converts its stored potential energy into the kinetic energy, which is the kinetic energy of the piston, but the air inside the piston gives transfers that kinetic energy of the piston into a bullet. So, how can we make a Nerf gun shoot faster? Now let's look at the original version when the gun is not modified, and the first and foremost thing is we have the Hooke's law, which is F is equal to minus kx. Here I have written mod, and that if we notice here is the mean position. I have taken a general spring and attached it to some platform, and it is being looked at like this. Now here, if you can see, there is no mass attached to it, no load attached to it, and when we cock the cock the gun, let's say when I cock the gun, so the spring somewhat contracts to x distance. So the potential energy formula is half kx square, and the kinetic energy formula is half k a square minus x square. Now, what the initial kinetic energy was half kx square, where x here is 0 because the spring isn't contracted yet. So initial kinetic energy was 0, and the final kinetic energy is where the final kinetic energy is when the spring is contracted to x distance, it becomes half kx square. Now, if you see the potential difference between the final position and the initial position, you can see it was half kx square minus 0, which is half kx square. Now, let's see the work done in this. The initial force, obviously it's not contracted, so it's 0, and when it's contracted or cogged, then at that time it is minus kx. So looking at the work done, which is f dot dx, we added the limit 0 to x, so we here took the minus k out, dx, which is also equal to minus kx square by 2, which is just the negative of the potential energy, which is obviously 2 because when it is contracted, we are doing work against the force of the spring, so that's why work done is negative and the spring potential is positive. Now, let's look at a few different terms. Acceleration, we already know F is equal to ma, so we just took m this side, and we got minus kx by m. So what we are taking here is omega square, whereas omega is equal to root k by m. So here it's k by m, so we took the omega square. And also acceleration is equal to v dv by dx. So we just put that thing over here and equated it to minus omega square x. Then here we took the dx that side and kept the v dv together and x dx together, integrated it. This is an indefinite integral, so we'll have a constant as well here. There was a definite integral, so there wasn't any need of constant. Here v square by 2 is equal to minus omega square x square by 2 plus c. Now we took 2 to that side since it's an arbitrary constant, so we do not need to multiply the c with 2. Now to determine what the constant c is, we took the velocity 0. Let's say, well, we'll come back on that later on. We took the velocity 0 and then we just did our math, which should be plus, sorry. Then what we realized was the constant was omega square x square. So we just got our constant and we put it back into our equation. So here it was v square plus omega square x a square minus omega square x square. Now how did we get a? Because this is at max compression, because if we have some if we are not at 0 or not at mean position, there is some acceleration which is against the velocity of the object. For example, if this is a string and this is its mean position, if we extend it here x and leave it, so the velocity will be here in this side, and here the acceleration would also be in this side. When it reaches here, it still has some inertia, so it will try to go this side, but now the acceleration is in the in the opposite side, because now the spring is contracted. So here that's why it is at mean position. If you look, velocity is maximum, it is at mean position. So, and that's how we put our equation together as omega a square minus x square. Now if you'll notice here, there is a graph of velocity in relation with x. If you look at this equation, it is in the form of an equation of the equation of an ellipse. Now, what we need to do is we need to check that in our case the amplitude of the contraction is x. So here this part is x. What we need to do is we need to check the displacement, the velocity from x to 0. So what we'll do is integrate this v omega root a square minus x square dx, and we'll integrate it from x to 0. Sorry about the delay. Now, after integrating, this will actually, this is a standard integration, so it will result in omega, bracket mein, I forgot it, so let me check. X by 2 and a square minus x square plus now this is the standard integration. Now this is the standard result we get. Now what is here important is that what the limits we have taken is minus x to 0 because it's this same, it's an ellipse. So this area will be equal to this area, will be equal to this area, will be equal to this area. So now we need to find this area and this area. Now as we know that here a square is equal to our x square, and x is actually our variable. So let's do that. So let's put x is equal to 0 and a square is equal to x square, sorry. So omega 0 by 2 0 by 2 and x square minus 0 plus x square by 2 sine inverse x 0 by x. So we get this term is 0 because here 0 is multiplied, here is x, but sine 0 is sine inverse 0 is 0 in fact. So this also goes to 0. So what do we get finally is 0. And the next part is where we keep it as minus x. Yes, minus x. Okay. So v finally can say, how is v final 0? We integrated it with respect to x, right? How come it's 0? Let's move this, and the final one is where x is equal to minus x. We keep it as omega minus x by 2 square minus x square plus x square by 2 into sine inverse minus x by 8, which is equal to omega. This whole term goes to 0 because these two eventually cancel out. So it will be, that is minus 1, and sine inverse minus 1 is equal to minus pi by 2. So what we get is minus x square by 2 by 4 actually, pi. So that area, this one, is originally it was minus x square pi by 4, and the entire area is minus x square pi, because you multiply it 4 times, so the 4 in the denominator will eventually cancel out. That is not our concern. Our concern was, so this is our area from minus x to mean position. Now the fact is, this is the first case, this is the natural case where the gun is coming from the factory. So we'll wrap up here for this episode.